This video we're going to be talking about multiplying and dividing rational expressions. Rational expressions are basically expressions that are fractions that we're going to throw x's, y's, z's in them, but they're most likely going to be shown up as fractions. So excluded values, they might also be called restrictions. Any value for a variable that the denominator, okay, so denominator means the bottom, of an expression gets me 0. So anytime I get 0 in the bottom, it is going to be an excluded value or a restriction. Okay, so state the excluded values. We only care about the bottom because if I get 0 in the bottom, so let's say I did 3 divided by 0, it would say error in my calculator. Okay, so that's the only part I care about. So if I solve this, I would divide by 12. So x cannot equal 0 because if it equals 0, I would have error in my calculator. Okay, my next one here, if I set it equal to 0, I subtract 1, x cannot equal -1 because then I would get 0 in the bottom. Okay, my next one here looks like I need to add 40 and divide by 25. Okay, and then you can simplify that fraction if need be. My next one here multiplies to -35, adds to -2 is going to be -7 and 5. And we're still setting it equal to 0, so I need to do my ZPP property. I set x minus 7 equals to 0, x plus 5 equal to 0. So if I solve this, I'd have to add 7, so x cannot equal 7. This should be x cannot equal 40 over 25. Okay, and then I would subtract this 5, so x cannot equal -5. Alright, simplify each expression, state the excluded values. So we're going to do our excluded values first. So I've got 15x minus 15 equals 0. So when I add 15 to both sides, I get 15 to the right side. If I divide by 15, I get x to equal 1. So x cannot equal 1. Simplifying, we look to see if we can factor, take a GCF out. Okay, it looks like there's a GCF in the bottom here. So I'm going to divide them both by 15. And then I'm going to get x minus 1. Since I'm now in multiplication mode, I can simplify those. They're both divisible by 3. So I divide by 3. And that's my simplified answer here. Okay, my next one here, we're going to be factoring. So multiplies to -6, adds to 1 is going to be a +3 and a -2. Multiplies to 15, adds to 8, so I've got x plus 5, x plus 3. Okay, when we get into this mode where we're separating them with multiplication and parentheses, I can cancel set things that are the same. Since this set is the same, I can cancel them. So I'd get x minus 2 over x plus 5. I cannot cancel my x's, okay, because they're being added and subtracted on the top. For example, if I had 4 plus 3 over 4, this is really 7 over 4. I can't just cancel my 4's and get my answer to be 3. Okay, so anytime there's adding and subtracting that's separating them instead of multiplication, you cannot cancel them. So for my next set, multiplies to 4, adds to 5. That's going to be 4 and 1. Multiplies to 20, adds to 9. It's going to be 5 and 4. When you have the exact same set on top and bottom, we cancel. Okay, so x plus 4, x plus 4, so I have an x plus 1 left, x plus 5, and I forgot to do my restricted values. So when I do my restricted values, I want all of my possible answers. So my factored form here is what I'm going to do my ZPP. So x plus 5 equals 0, x plus 3, because I want all of my possible times where I could get 0 in the bottom. So x cannot equal -5 and -3. My next one here, I want all my possibilities, so before my canceling. So x plus 5 equals 0, and then I would also have x plus 4 equals 0. So x cannot equal -5 and -4. Okay, now we're going to be multiplying and dividing. So multiplying, it's kind of like just a big fraction bar. If you want to represent it as a big fraction bar, put some parentheses around everything, you can. Right now, my sets that are the exact same on top and bottom are my 3's and my x plus 3. So I have x minus 6 left and a 4. I cannot simplify 6 and 4 because of that subtraction sign sitting there. Okay, my next one here It looks like these are the exact same on top and bottom, so we could cancel, and I would just have a 2/3 left. Okay, multiplies the -16, adds to 0 is going to be 4 and -4. If you want to represent this as a big fraction bar, multiplies the -90, adds to 1 is going to be a +10 and a -1. Multiplies to 40, adds to 14 is going to be 10 and 4. And then I want to flip-flop this. So I'm going to have my x come first. So it's going to say -x, and it is a +9, so +9. And then I don't like having my front end thing negative, so we're going to take a -1 GCF out. Anytime your front end thing, like your x squared or your x is negative, take that negative out so that it represents x minus 9. Okay, so when I'm going through, oops, that was supposed to be a 9 back there. Now, because they are matching, I can take them off. I've got my x plus 4s and my x plus 10. So really what I have left is x minus 4 divided by -1, which we could also write as -x plus 4. Okay, it looks like I got a GCF in the top there of 2x. So remember, you can't lose them when you take it out. So it's going to be 2x times x minus 6 over x plus 5. If I want to change my division to multiplication, it's the same as multiplying by the reciprocal. So I can multiply by its flipped and get the exact same thing. Now I could write it as a big fraction bar if I wanted to and do all my parentheses. I've got my x plus 5s, my x minus 6s, so really all I have left is a 2x. Okay, so we're going to flip that back end. So it's going to be times 5x cubed minus 35x squared over 9x minus 36. Looks like I have a bunch of GCFs on that right side there. So I've got 5x on that top part, 5x squared because I got 2 x's in common. So I would have x minus 7 left. I've got 9 in the bottom, so I've got x minus 4. 5x squareds could cancel, so really all I have left is this right here. Okay, we're going to flip our back end again, and then I want to reorder this. So I've got my x squared, my minus 7x, my plus 8, so get it in standard form, and then take out that negative. So -1 is going to sit on the outside when I do my flipping here. I've got x squared, come on, plus 7x, minus 8, because it's going to flip all those signs, over x plus 8 times, we flip it, so x plus 5 goes on top. That bottom, that 9 actually has a GCF, so I'm going to pull it out as I'm flipping. Now we can factor. Multiplies to -8, adds to 7, is going to be 8 and -1. And now we could write it as a big fraction bar. We can cancel these, we can cancel these. So I've got -1 times x plus 5 over 9 left.